Okay, so picking up from last time, the data set downloaded, and we see it here as the SRA FASTA. So if we haven't seen, I'm sorry, FASTQ. So if we haven't seen FASTQ files before, what we can do is just use the text editor to preview what it looks like. Um, these are very large files, so this may actually present as problematic depending on how big the file is. There's another way of getting a preview of a large file, and we can see text editor, God bless, it's trying. Um, what we can actually do is stop that process because it's not going to have a good time, and we can do something else. So in Mac, we can go to terminal, and PCs are a little bit different. You'll have to do this in the command line, but what we can do is go into terminal, and then we're going to be using some Unix commands to speed things up a bit. So this requires a separate set of practice and learning what these commands do. What I'm going to do is use one command called cd, or change directory, and I'm going to use some, for lack of a better word, shortcuts using the graphic user interface or graphical user interface that Mac has. One way that you could get to do what I'm doing is you could do cd, and then you would have to remember all of the, well, okay, what we can do actually is, and we have to select this window just by clicking on it, we can clear everything and we can do something called print working directory, so pwd, and then hit enter. Notice that there isn't a space there. So this is just where we are in this computer. So this is users derp. Derp is just kind of my like extra profile to be able to do stuff. So print working directory. What I can also do is I can list to see what is inside of derp. And again, derp is the profile that I'm using on this machine. So by doing that, so listing stuff or listing contents, that's ls. And so these are the folders that are in here. And so notice that what I want to do is I want to get into this downloads folder, and we can see that downloads is already here. So what I can do is change to download, and I can just, let's say if I start typing D, there's a couple of folders that have, or I'm sorry, directories that have, that start with D, so like desktop, documents, and downloads, so DO. If I typed that, it gives me a couple of options, so I can just hit tab, or actually no. So yeah, so if I hit tab twice, it will give me a couple of options that I can pick from. So if I do DOC, then there's only one, and if I hit tab again, it'll autocomplete that, which is available. But I want to go into downloads, so I want to hit W, and then I go into downloads. So I can do that, and then this just confirms that I'm in the directory downloads. Before, whenever I was just starting, I was in the directory derp, and then we can see that derp is a directory that's in the users folder. That is in the directory that's in home, the home folder directory, I'm sorry. So another way of doing that, just if you're using Mac, and I think you may be able to do this with PCs, I'm not super sure. But let's say we want to go back to derp, so we can just do cd, and hitting two dots brings us back up. What we can do is pick cd again, and then a space, and what I can do is I can click on this folder and I can drag it. This is super, super easy to do, especially if you have a bunch of directories and you like to kind of mix working in the command line versus actually being able to easily look at your files. So this just gets us to derp again, so this is two ways of doing that. I'm doing this to be able to preview the huge text file that was, I'm sorry, the huge ASCII, or ASCII, I forget how you say it. But so that type of file that has that type of encoding, or those type of symbols, that it's not compressed and that you can actually look at it. If you try to look at those large files in a text editor, you're going to have a problem because the entire file isn't going to easily fit into memory on most machines. And this isn't a this isn't a bad machine. So one of the things that we can do is there are a few different commands to actually start exploring the file. Head is one of these, and we can just do head, and then what I can do is drag the file here and note that it'll give me the file with the path. So otherwise I would have to remember what the path is, but keeping in mind that I'm in derp, another way of doing this would be to just start typing the name of the file that I care about, assuming that I know that the file is in there, and then I can hit tab, and if I type in everything, if I type in enough that is unambiguous between other files, then it should be able to autocomplete. So those are two ways of doing that. So I just want to see the beginning of this file. So head by default will give me 10 lines, or like 5 or 10 lines. We'll see how many lines it gives us. Just stretching this out a little bit. So its output is here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it gives us 10. And then if we wanted to learn more about any of these commands, what we could actually do is type the word man for manual, and then we can type in the name of the command. So in this case, it was head, and then we hit enter, and then it gives us a little bit of a synopsis or a summary of what this machine does whenever you type in that command. And so head is very, very simple. And then tail is another command that gives us the opposite. So instead of the first however many lines, you can actually do the ends of the file. This is actually a really useful command to be able to actually do some quality control to make sure that you have the beginning and the ends of certain files. And so this is just, these are the last 10 lines in this case. So that's that. What else? What else? So this is what this data looks like, and you don't have to look at everything. If you wanted to look a bit more, what you could actually do, ironically, is type in less and the file name in this case, and remember that we're in downloads. So this just lets you scroll through, and it starts at the beginning of the file. So if we start at the beginning here, we can just scroll down and down and down, and if we wanted to waste our lives, we could actually scroll down to the end of this 3 gigabyte file and get to that point. So that's not a super efficient use of one's time, but sometimes you actually do have to, unfortunately, do that type of thing. So to get out of this view, what you do is press Q, and so you get back to the command screen, or the command shell, I guess. Shell box, shell window. Yeah. And so, okay, so we know what this data is supposed to look like. We know that it is a FASTQ file. The main difference between FASTQ and FASTA is, remember, just a file, and this is a pretty small one, so we can look at it with text edit. FASTA just has one line that's a name, and so this is kind of broken up just because the line's a little long, but this is one line with a name, and it has a little caret, and then it has sequence information for the rest of the file. Okay, and all of that is one line, although it's broken up into different lines with characters that you don't necessarily see, but they're there. They're new line characters that are usually not usually visible. So you can get rid of that, and then that is different than. Ooh, this was the file that we tried to open before, and God bless TextEdit for trying. So we can go away. We don't need that. And then this is different because it gives us the sequence information, but then it also gives us a few other things. So this is the information from one line. This is identifying information. This gives us the name, from what I remember, of the DNA read. This gives us the orientation of this read. These are all forward oriented. And then the length is 76 base pairs. So that's all going to be useful for whenever we bring this into Galaxy. So, okay. Thinking about what we're going to need to do, we're going to be mapping that data to a reference. So we need to check to make sure we have that reference. So the files that we downloaded previously, from the Los Alamos, or not Los Alamos, I'm sorry. So it's organized in Los Alamos, but it's hosted by NCBI in the genome, I think, database. But this is the K03455, otherwise known as HXV2. This is the canonical reference for HIV-1. And so we want to see whether or not we can actually detect HIV reads in this sample, and then we'll do a little bit of a deep dive to make sure we understand what that means. So if we find one read that happens to map kind of well, or like maybe not necessarily that well to HIV, that's not really supporting the presence of HIV in the sample. That could just be one of millions of reads that happen to have some type of homology by chance. We'll talk about what a realistic expression pattern looks like. And to be able to do that, we actually need to download one tool before we actually get into to Galaxy to be able to do the analysis. I downloaded it previously on another profile, so I just want to check to see if it's not already in here. So it does seem like I do have access to that other program, which we'll be using, which is this. However, what I want to do is show y'all how to download it. So what we'll do is just go into the Googles. Then we'll be looking for the Integrative Genomics Browser, or IGV. And it's our first hit over here. So we click that. And then this is going to be your best friend. This is a cheap open source software that will be very, very useful to do exploring of different types of sequencing data sets, including a lot of epigenetic studies, a lot of open chromatin studies, and things like that. To download it, what you'll do is just go over here, and they'll give you different versions for your different softwares. I think my version is old, so what I may want to do is actually re-download it. So in this case, I'll do the one for Mac. I'll do allow. Okay. It'll take a little bit of time. It's not that super small. That's not that bad. Dude. So while that is running, what we can do is actually go into Galaxy and start moving our files there, because that'll take a little bit of time. What we are downloading is a tool that will allow us to look at the analyses that are being done in Galaxy. Galaxy does have ways of visualizing data, but they're not as quick. So one of these for lack of a better word, servers or services, just because it is kind of like a cloud environment. So it's not necessarily one server, it can be many servers. But one of these environments is usegalaxy.org. This is the main instance. And then there's also usegalaxy.eu. I like using usegalaxy.eu because, and EU stands for .Europe, or .European, I guess, or European Union, one of those things. It's hosted in Germany, but the other server usually has slightly different tool sets, which may be more or less useful depending on what you're doing. But we can actually compare what is available. So in one tab, I'm going to open up usegalaxy.org. In another tab, I'm going to open up usegalaxy.eu. I'm not going to sign into either of these just because I don't necessarily care about saving this data set, because we'll be organizing this in a slightly different way. But then the other thing is that once you have some of these files, it's very easy to do this type of analysis. So what I care about from y'all's perspective is y'all being able to actually write out what method you're using, document the needed level of detail, which I'll go over. And then once you do that, if you need to repeat it, you can, or if you finish your results, you can do something called publishing them in Galaxy, which isn't the same thing as a peer-reviewed publication, but it is a way of saving your progress and making it available for just you or your collaborators, but then to be able to publish, from what I remember, you actually do need to sign in. So we won't be able to do that in this demo, but we will be doing it for our project. So okay, we're in usegalaxy.eu. What I want to do is actually just do a side-by-side comparison. So I'm going to pull this up as a separate window, and we're just going to look to see side. No, I don't want that one. Okay, you and you. So side-by-side comparison, not the easiest way to explore this, but it gives you an idea. Um, there are different tools available. So we start to have just the walkthrough. I can start on here. The tools tab is going to be on this side on the left. These are many different types of tools, and it goes along the spectrum of bringing your data into this environment, doing things to make sure that your data is in the right format or in the not just formatting necessarily, but making sure that your data is in a form that is expected for different types of tools. And then you can do things like quality control, you can do things like mapping to reference, you can do things that are technology specific. So Nanopore is a type of DNA sequencing tool, alignment stuff, or I'm sorry, so like FASTA-FASTQ formatting, that's not necessarily specific to a given technology. This is just how we represent DNA or some types of sequencing information. And then we also have some other types of analyses, like RNA-seq analysis, variant analysis, and some other things, and then some other tools. Um, and then what you do is you bring in your data, you start working, and then your history will start to be populated. And then this middle pane will give you specifics about whatever tool you're doing. Um, and so that's that. And then over here you have so over here you have the link to register, which is very important. Everybody should have that done by now. And if you want, you can actually start doing this type of thing in your environment. You don't have to be outside. And then also it'll give you a space bar to let you know how much space you're using. So I think with most individuals, each will have something like 250 gigabytes of space that you can use on their or in their environment. And you can run, I think, something like 6 jobs an hour. That may have been updated recently. Um, Another important thing to note is that once that space gets filled, then you need to actually get rid of junk that you're not using. So that this is why we're actually dividing what we're doing in parallel, so that we can actually do a bunch of work at once and then compare the results, and then we can write them up and summarize them. Other details, so I'm introducing y'all to the main instance and then the European instance because right now they are separate, or at least the last time I used it, they are separate, which means that effectively you have 500 gigabytes of space that you can use. If you're working on a really, really big project, like whenever I started actually doing this previously, what you can actually do is write to the Galaxy folks to ask to have more space. So, and by more space, I mean terabytes of space. But that is usually only reserved for special cases and limited amounts of time. So I think by dividing these types of jobs up, besides having it be a learning opportunity for y'all, you actually are able to do more work, I think, in a more effective way. More eyes working on a problem are always good. So, okay, what are we going to do? We're going to bring in the data that we just downloaded with this, and we're going to do this in both. And then once it's thinking, then we can go through what some of these other things do. So I'm going to choose my local files. We're going to make sure that we're in downloads. And then, so we want all of these references because we're going to be working with HIV. Oh, actually, before I start doing that, just to be efficient with our time, remember that these samples were skin biopsies from HIV positive patients that also had Kaposi sarcoma. Kaposi sarcoma is associated with human herpes virus 8. So what we're going to do is we're going to just find a reference for human herpes virus 8 in the same way that we found references for HXV2. So we're going to go to NCBI, or actually there's a couple of different ways that we can do this. So there's, I think, the virus genome database, viral genomes. This is a good resource to have. What we're going to do is we're trying to find HXV2. So viral zone is one good central, I'm sorry, not HXV2. Viral zone is a good European-based resource, but it also provides an easy way for looking at reference genomes. So just type in human herpes virus 8, and then oops, what does it give you? It gives you this little bit. So we want to make sure that we can look for that. So we can just click what this is. Yes. We can see if we can jump in there. Human herpes virus 8. No. This is giving us proteins. Interactions. So this is just a general entry for herpes viruses. What I want is I want genomes for human herpes virus 8. Disease, host species, proteins, host interaction species. I can click species. These are different types of human herpes viruses. I don't want some of these. So this isn't working for that, which is okay. Data. Genome. Maybe if I go to genome organization, this gives us an example of HSV1. It's not what I want. Doot. So that's okay. We can go to the viral genome browser. This is another way of getting virus information. And all of these links are very, very useful. So it just takes a little bit of kind of digging to find what you need. So okay, we have a lot of these. What I'm going to do is narrow my search down. So this is something like 10,000 different viruses that infect all living organisms. I'm going to narrow this down to human by filtering by host. And then and that gives me 500 genomes. And then I think at this point, because it's not, in this case it actually is showing me, so like I can scroll down. But what I can do is I can do Control F and look for HHV8, or I can type Kaposi's, or KS maybe. No. So that's not working. Okay. So otherwise, we'll just have to see if we can find this. So human herpes virus 4, type 2, so this is EBV. Merlin is CMV. Alpha. So alpha herpes viruses. HSV1. Okay. I forget exactly which family of herpes virus HHV8 falls. So we are going to do the dummy version of this. And just go to wiki. Another way it is abbreviated that I've seen is KS, Kaposi sarcomas associated herpes virus. So maybe KSHV. KSHV. No. So that's not there. What else? What else? So we're looking to see what kind of herpes virus it is. So it's a gamma herpes virus. This may help us with the name. So human gamma herpes virus. So what was the other thing? And part of it is the virus nomenclature is not great. So Radino. Yeah, no, it's not on there. Just want to make sure the search is working. So this is working. Add wildcards. Nope. Which is annoying. So it is a gamma herpes virus. There is a more specific way of looking for this genome, but I'm trying to introduce you all to some other resources. So we can just check what these gamma herpes viruses are. So from what I understand, Raji is an EBV. Yeah, so EBV. So go back. It's not that one. Let's see, 8. Yeah, there we go. Okay. So this is what we want. And then we can go and click on genome. And hopefully this should take us to the NCBI page for this. It does. Human gamma herpes virus 8. And then we have some other things that we've seen before, the rhodinovirus stuff. And we have some other statistics that are pretty useful. How big is this? It's 137 kilobases. What is the GC content? It's about 53. This is higher than the average human genome or GC content, which is around 35 to 40%. GC content means how much of the ACGT components of the genome, like how much of the genome is either G or C. So, and this has some interesting bioinformatic some bioinformatic implications. There are 83 known proteins, and there are 96 known genes. And it's all modeled. If you actually go back to that viral zone page, and we look at herpes, herpes are pretty similar, but each one does have their own unique aspects. But you have these repeat regions, and then you have these longer interspersed units, and then you also have like a shorter interspersed unit. This is the model for the genome, and realistically, we actually don't know what the genome really looks like between whenever the virus is making multiple copies of itself versus whenever it's in a latent phase. We think that it turns into a circle and kind of hides out like its own little chromosome, but realistically, we're actually still trying to figure that out. Or people that know about the limitations of the technologies that have been used previously to look at these problems are still trying to figure it out. So we can go into RefSeq, this entry for HHV8. So GK18 is the strain of this case, or the strain of the virus in this case. So what we'll do is we'll do the same thing that we did before, but we're going to be lazy and we're going to click what is this? The accession number, and then, excuse me, we're going to have accession number underscore and then GK18 for HHV8. So we want, remember, we want GenBank full, create file, that's fine. We want FASTA, create file, and then we also want the GFF3, which is, I forget what it stands for, but we'll get into that formatting. This is an annotation format. Create file. Okay, so we're good there. And then for whatever reason, it decided to open this up, and it's going to freeze because it was trying. And then we don't want it to freeze, so we can tell it to stop. Okay. There we go. Just jumping in. So the things that we just downloaded are up here. So we're going to start renaming them because, again, we don't want to have these run away on us. So GK18. And then what we're going to do is just copy this name. So that was the GenBank file, which is the .gb. This is just the FASTA, or just the nucleic acid sequence. And then we're going to change the GFF3. Okay. And then so for GFF3 to work, actually, you want to get rid of the .text at the end. So we're going to do that for this, and then we're going to do that for the HXB2. And now we're going to be bringing these sequences into Galaxy, both galaxies. So what we're going to do is choose local files. We're going to select all of these, and we can do this in order. So we'll do, let's say, GenBank. Although, so for this exercise, we actually don't need to import the GenBank. So we just need the FASTAs. So we want HIV FASTA, and then we want this HHV8, or the GK18 FASTA. And then we also want to bring in our dataset. So we can choose that. And just reviewing to make sure I have everything that I need. We choose that, and we can make sure we tell it what types of files these are. So these are going to be FASTA. FASTA, and then this last one is a FASTQ. FASTQ. And then this is, it's encoded with Sanger, so we're going to say FASTQ Sanger. And then it's not compressed, so we don't have to worry about these. The file extensions. And so Sanger is a type of encoding. That's the quality control, and it's really important to make sure that you click that instead of regular FASTQ. Otherwise, the tools won't necessarily know how to work stuff. So this area would be if we were working with an animal genome data set, but we're not right now. So we're just going to leave this blank, and then we can start. And then we're going to do the exact same thing. Ooh, that's a problem. Okay, so this is too big, which is okay. What we're going to do now is we're going to look at, and so what we're going to do is actually compress this. So we can just in here do compress, and then the default setting is to, oh yeah, that's very, very big. So I didn't realize it was that big. So we're going to do .zip in this case, which is the same thing as gzip from what I remember. We may actually need to, I don't think, yeah, so that's okay. Reset. So FASTQ, we just need to check to see what it can accept. So it can accept BZ2 and gzip. .zip is not the same thing, so we're going to stop that. And then we're going to get rid of this compressed deal because it's not helpful. We're going to have to go back into command line, and then I need to decide which is going to be better for compression. So I usually use gzip. So I haven't used gzip in a while. I think it's just typing in gzip, and then the, we can do it this way. So man gzip is the command that we would use. It is installed on my machine because it's a common compression thing. And then it gives us just a little bit more information of what options to pick. So I want to keep the compressed and uncompressed because I don't want to necessarily lose that uncompressed one. So we can look at examples. Usually it gives us examples of usage. I'm giving it the file name. If I wanted to decompress the compressed file, I would do gzip and then space hyphen, or I guess dash d space and then the name of the file. And then we can do, okay. So what we can do, just type in Q. We're in derp, so we're just going to need to cd into downloads so that I can see what's going on here. So that's fine. And then I want to gzip this, not this one. This was the one that's in a weird format that we can't use directly. So I want to gzip this. And then ideally I would want to keep that file. So I just want to look at examples of gzip. No, that's not what I want. 11 simple gzip examples. Yeah, there we go. So compress, and then so we're going to move around here. So select that, and then if I hit Option and arrow, it lets me zoom in a little bit quicker. So I want to compress this file, and I want to change it to, let's say SRA data dot, or actually no. So what I wanted to keep that other file because it had the SRA name, but I have that here, I think. So I literally just want to keep that name. So we're just going to do that, and then SRA underscore data, SRA underscore data. Actually, I want to keep, sorry, data. It's useful to think about what format you want your stuff to be in, and then if you keep SRA in the front, then you can sort a couple of different ways. And then I want this to be fastq, and then it should add whatever other ending thing it needs. So I think in this case it'll be a .gz. So this should work, and it'll take a little bit of time. And so we will come back whenever that's done. Oh, and then the last thing. So whenever it is done, it will bring this new line back. So it'll look like my username and then derp dash. So it'll be a new line. So we're monitoring progress here. We're also monitoring progress over here. And it'll take a little bit of time because the overall file is something like 10 gigs. So we will be back.